We're here to take airborne geophysical survey, mainly magnetic and gravity surveys, in order to better understand the geology at the surface and also the geology at depth.
So the magnetic data and the gravity data, it'll allow us to look for rock types that are basically the same over a large area. We'd also look for different locations where there might be potentially faults or fractures, and then those would be certain features that we'd want to stay away from. So in the end, we're kind of looking for a large block of rock that is free of faults and fractures.
We have what we call blocks, and in the blocks there are lines that have 100-meter line spacing. The control lines, those lines flying north-south, and the control lines flying east-west have 500-meter line spacing. We're trying to be sensitive to the people on the ground, so we're not going to fly over an area repeatedly. We'll try to go 10 kilometers, 3 kilometers away from our return line, but we'll go downwind and then upwind and then kind of do a racetrack pattern, simplify it like a Zamboni on the ice, kind of catching everything. But people would see an airplane flying about 300 feet off the ground, higher over the urban areas.
So the magnetometer that's here equipped on the aircraft, it's very sensitive to the different mineral types that are in the rock. Some of those mineral types become magnetized by the Earth's magnetic field, and then as you're flying over, you'll get a different response from the magnetometer. And each different rock type has a different response. And then you can start to put all that information together and form this nice map, which will show the different locations of the different rock types in the area that's being surveyed.
The data that we are collecting will be used by experts and specialists in the area. They will analyze it, and they will produce new maps of the geology and new maps of the distribution of faults and fractures, if any are present. And we will use that information to assess whether it is possible to find small areas that are potentially suitable for hosting a repository. If we find areas that are potentially suitable, the next step will involve geological mapping or walking the land, because we want to verify in the field that what we understand from the surveys is accurate. So we will be doing geological mapping, and that will involve people walking the land, taking notes, looking at the rock types, looking at superficial fractures. But it is important to note that all what we are doing here, we are doing it in collaboration with the communities. So we are planning the activities with the communities. We will share the results with the communities, and any potential site that is identified for drilling will be chosen with the involvement of the communities.